So we're going to talk about something in geometry that we refer to as Cpctc, and we call it this because its elongated name is quite a mouthful. So Cpctc officially stands for corresponding parts of congruent triangles are congruent, but we're going to extend it to congruent figures. So we're going to be looking at all kinds of polygons or all kinds of figures, but we are going to focus mainly on triangles. We are going to have a couple other shapes in here. So when we're talking about this, we're going to say all corresponding parts, sides and angles are congruent. So we've seen corresponding before in parallel lines cut by a transversal, and corresponding essentially means kind of in the same relative location, so relative to what's around it. So if I'm looking at these two figures, they're essentially the same figure, except one of them has been flipped and looks slightly different, but we can still name a bunch of corresponding parts here. And we're going to name some corresponding angles and some corresponding sides. So first up, we can take a look at these angles down here. So angle C would be congruent to angle D. And then next, we can kind of move up the figure and say that angle S is congruent to angle V. And we're going to keep going around working on this. And we're going to be consistent about the direction in which we're going. So if I go from C to V, or D to V, I want to make sure to go from D's corresponding part to V's corresponding part. And then I want to keep going in the same direction the whole way to get all the corresponding parts. So angle R is going to be congruent to angle T. And then lastly, we're going to have that angle B is congruent to angle E. Okay, now we can get into the congruent sides. Those are the four congruent angles. Now we're going to have four congruent sides as well. So this is where direction really becomes important because we have to write these sides in very specific ways. So we're going to start with side CS. So CS is congruent to, and if I went from C to S, then I need to go from D to V. So DV. All right, so order is very important. So that means that SR is congruent to VT. RB is congruent to TE. And last, we have that BC is congruent to ED. All right, so make sure you have your appropriate segment notation and make sure you're consistently going in the correct direction depending on where you started from. So what we can do after we have all of this is we can write what's called a congruency statement. So the congruency statement is going to tell us the order in which different things are congruent to each other. So if I can say that triangle, and I can say CSRB is congruent to triangle, and then I need to list in order the congruent parts of the other triangle. So C is congruent to D, then S to V, R to T, B to E. So the placement in the congruency statement is going to tell you what bits are congruent to each other. That's the purpose of a congruency statement. So now we're going to get a little bit more in depth into the Cpctc part of things. The corresponding parts of congruent triangles are congruent. So we're going to look at these two triangles. So it's giving us a congruency statement. So the first thing I'm going to do is kind of, since we're a little bit new at this, I'm going to highlight the corresponding parts. So Triangle ABC is congruent to triangle DEF. So that means A is congruent to D, B is congruent to E, and C is congruent to F. So note how on the base of this triangle, that might not have been the order that you were completely expecting that to be in there. So you do have to be very careful and read your congruency statement quite closely. So it's going to ask us to compare a couple of sides. So I'm going to use congruency markers real quick to compare these sides. So AC is going to be congruent to DF. So from green to blue and then green to blue again, which means AE, green to red, is going to be congruent to DE, green to red. And then BC, red to blue, is going to be congruent to EF, red to blue. Okay. Now I'm just going to focus on the figures here for a moment, and I'm going to worry about filling in the rest of this after I've filled in my figure completely. So if angle A is 60 degrees on one figure, then its corresponding part, angle D, is congruent to it. So that should also be 60 degrees, which means B, my red angle, which corresponds to my other red angle, angle E, is 68, which means its corresponding angle, angle E, should be 68. So now we can use the triangle angle sum theorem. So we know that all three angles in a triangle add up to 180 degrees. So that means 180 minus 60 minus 68 will give me my third angle, which is going to be 52 degrees, which means C's corresponding angle, angle F, should also be 52 degrees. And we can fill in the side measurements as well. So anything with 2 tick marks is going to be congruent to the other 2 tick mark side. So AB should be 12. DF is congruent to AC, so that should be 14. Again, single tick mark, single tick mark. And then triple tick mark to triple tick mark, this should be 13. And you can put units on there too. Units never hurt. So now that we have our figures completely labeled, let's go ahead and just take a moment and fill in these measurements. So we said that AB was 12 inches, DF was 14 inches, FE was 13 inches, the measure of angle C was 52 degrees, D was 60 degrees, angle F was 52 degrees, and angle E was 68. So Cpctc is typically easiest to work on the figure rather than on in the abstract, trying just to do the numbers on your own. Okay, so in the spirit of working on the figures, when we come across a problem like this, where it says triangle fox is congruent to triangle cat, we want to draw these figures first. It's just going to make your life a lot easier as far as organization. There are other ways to do that, but just drawing the triangles is probably your easiest. Also, if it asks you to find the unknown measurements, if you want to just list them on the figure, I'm okay with that. So this is triangle FOX. So we can set this up so that the corresponding parts are kind of actually sensibly in the same location. So FOX and then CAT. So I'm just going to go ahead and stick on some congruency markers. So FO is congruent to CA, OX to AT, CT to FX there, okay? And then we'll fill in what we know. So we know that angle F is 90 degrees, so I did not draw this to scale. Angle A is 25 degrees. FO is 18.1 centimeters. TA is 20 centimeters. And FX is 8.4 centimeters. So we just want to use that in order to fill in the rest of this information. So according to our diagram, FO is congruent to CA, so that'll be 18.1 centimeters over here. AT is congruent to OX, so that'll be 20 centimeters. FX is congruent to CT, so that'll be 8.4 centimeters. And now we can start filling in the angles. So angle A is congruent to angle O, so that'll be 25. And then we want to go ahead and use our triangle angle sum theorem. So we're going to do 180 minus 90 minus 25. Find our third angle is 65 degrees. And I can put degree markers on here, be a little bit more accurate. So we know angle F is congruent to angle C, so that'll be 90 degrees. Angle X is congruent to angle T, so that'll be 65 degrees there. So now we have filled in all of the parts of our triangle. Okay, so last thing we're going to look at is simply called the third angle theorem. So honestly, even without Cpctc, this is something that we would assume. The third angle theorem says that if two sets of angles in two triangles are congruent, then the third angles are congruent. So this is something we probably would have guessed if we had a 90-degree angle and a 40-degree angle, and we had a third triangle where we had a 90-degree angle and a 40-degree angle. Well, in both triangles, there's only one option for what that third angle should be. So of course, they're forced to be congruent. So we know a couple of other things. So if we want to say that two triangles are congruent, completely congruent, sides, angles, everything. So there's 6 parts to a triangle, 3 angles, 3 sides. These are the things that we will need to know. So the third angle theorem only tells us about the angles, but I could draw a really little triangle that had a 90-degree angle and a 40-degree angle. And I couldn't call those angles congruent because their sides might not be the same, even though their angles are congruent. So in order for the whole triangle, two triangles to be congruent, these are kind of the sets of items that we need to know. So first thing that we can know is if we have all three pairs of congruent sides, then we know that the angles are going to be congruent. And if we have that and 2 pairs of congruent angles, then with that third angle theorem, we know that the 2 triangles are going to be congruent. So we need those 3 sides for now. We do need the 2 angles, and then the third angle theorem picks up that last 6th piece of the angle.